determination of pK value of given weak acid. This experiment we have already discussed in our theory, right? So application of glass electrode. So one of the application of glass electrode is determination of pH. But here we're going to determine the pK of given weak acid. So what is weak acid? So weak acid is the acid where dissociate partially when in solution. So we have two types of acid. So acid, strong acid is the acid which dissociate completely into its respective ions when in solution, whereas weak acid is the acid which dissociate partially when in solution, right? So here now determine pKa, it can be determined only to weak acid and not strong acid. So why? Because strong acid dissociates completely. So since strong acid dissociates completely, there is no Ka factor. So Ka is dissociation constant of acid, right? Ka means dissociation constant of acid. So negative logarithm of Ka is pKa. Negative logarithm of Ka is pKa. So Ka is acid dissociation constant. So this acid dissociation constant is available only for weak acid and not for strong acids. Therefore, pKa can be determined only for weak acids. This is the first point. So what are the accessories? So we want NaOH, it will be taken in the burette, and in the beaker we are going to take weak acid, any weak acid for that instant. Okay. So electrodes, reference electrode, calomel electrode, and glass electrode, and pH meter. So we're going to measure the pH and in turn we're going to determine the pKa. So how you're going to determine the pKa by measuring the pH? That is a big question mark, right? So I've told you're going to determine the pK here, but I'm telling you're going to determine pH. So how? Let us discuss. So here the main thing is the pKa and strength are inversely proportional to each other. So pK of an acid and pH and pK are inversely proportional to each other. So you can see here, so the acid will dissociate and will give you the respective ions. So pKa is determined only for weak acid, is already we have discussed. So here, according to the Henderson-Heisenberg equation, pH is equal to pKa plus log of concentration of salt by concentration of acid. So here we are going to take acetic acid. We will take acetic acid, we are going in the beaker, we are going to take in the burette NaOH. So we are going to dip two electrodes. What are those electrodes? Indicate electrode, that is glass electrode, and calomel electrode, reference electrode. We are going to add NaOH in increments of 0.5 ml. For every 0.5 ml addition, we are going to measure the pH. pH will slowly increase. So near the end point, there will be a neutralization reaction. NaOH versus HCl, it is a neutralization reaction. So neutralization reaction, isn't it? So when the neutralization is over, so what happens again? pH will slowly increase. So here, when pH will become equal to pKa at half equivalence point, that is when concentration of salt is equal to concentration of acid, so pH will become equal to pK, that is according to Henderson equation. So what is that half equivalence point? That is when the concentration of salt is equal to concentration of acid. At equivalence point, entire acid will be converted to salt and water. So before equivalence point, that is before equivalence point also, there will be some amount of acid which is not converted to salt and water. So exactly at half equivalence point, half of the acid will be converted to salt and water. That is, reaction is half complete. When we substitute the concentration of the acid at that particular time, so what will happen? The concentration of salt and concentration of acid will be equal. So log 1 is 0. pH will be equal to pKa. So according to Henderson equation, pH is equal to pKa at half equivalence point. Why? Because at half equivalence point, concentration of salt will be equal to concentration of acid. Okay, so therefore, that is the basic Henderson equation. So initially, we are going to pipette out 25 ml of given weak acid, any given weak acid. But here we are going to take the acetic acid. going to immerse the calomel electrode and glass electrode assembly into the solution and connect it to the pH meter. We're going to add NaOH in the increments of 0.5 ml, stir and measure the pH. For every addition of our NaOH, we're going to measure the pH. So pH increases slowly or gradually. So near the neutralization point, there will be a sudden jump in pH. Okay. So we're going to, after a sudden jump, we're going to take 4 or 5 readings and stop the experiment. We're going to take the first derivative of pH with respect to volume and plot a graph of delta pH by delta V versus volume of NaOH and determine the neutralization point or equivalence point. And plot and determine the half equivalence point. Okay. So later we are going to plot another graph of pH against volume of NaOH and determine pH at half equivalence point, which is nothing but pKa. So the nature of graphs are as follows. So once the experiment is over, it is tabulated, we are going to determine delta pH, calculate delta pH by delta V. Later, we are going to plot a graph of delta pH by delta V versus volume of NaOH. The nature of graph is as follows. So from the peak, we are going to drop a perpendicular to x-axis. So whatever it comes here, that is the equivalence point. So if it is 5 by 2, it is half equivalence point. If it is 5.5, 5.5 by 2, it is half equivalence point. If it is 5.5 by 2, it is 2.75. Is it right? So it is half equivalence point. If it is 6 by 2, it is 3. 3 is the half equivalence point. We are going to plot another graph pH versus volume of NaOH. The nature of graph, it will get S type. Okay. So from the volume of NaOH, from half equivalence point, we are going to take draw a perpendicular until it for parallel line to y-axis until it touches the curve. From there, we are going to draw another line until it touches the y-axis. That gives you the value of pKa. So we are going to do the demonstration of the experiment, tabulate the values, and we have going to plot the graphs delta pH by delta V versus volume of NaOH and also pH versus volume of NaOH and determine the pKa. There is no calculations here, only the graphical values. So the demonstration, tabulation and graphs for everything, click the below link. So in this link, everything is available. So please click the link for demonstration of pKa experiment. Thank you.